This lesson is the second of 2 days, where the first day we talked about corresponding parts and really emphasized when we worked with congruent triangles how to prove them congruent using side, 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 and side angle side, and then the corresponding parts of those triangles. We're going to review over that during this lesson, but we're going to focus on at the end doing some proofs and how to prove triangles congruent, which we'll build upon over the course of this chapter. So what I'd like us to do is follow this agenda. We're going to start with an opening, and that opening is on your note sheet. I'd like you to take a look at this diagram here and name all the angles in this diagram. I want you to be careful because especially I'm going to focus on the middle here with this angle R in the middle. Notice that there's multiple angles there, so make sure you identify it properly. So take a moment, identify all the angles, and then pause the video to do that, and then come back when you're ready to take a look. Let's take a look at what you got. Okay, so over here, notice that with this angle up here, we can identify that angle as angle R, or angle V. It is by itself the only angle there. Now, we could identify it also, I'm going to put it off to the side here, angle PVR or PVR or RVP, as long as the V is in the middle. So if you want to use 3 letters, you can do this, but we're allowed to just say angle V because there's only one angle there. Same with angle P. Angle P could be listed here by itself, or if we wanted to, we could list it with 3 letters. We could do VPR instead. Okay, these are the same angle there, listed there. But to be clear, when I get to R here, I can't just list angle R because there's actually 2 in the triangles and also 2 outside the triangles that we can't identify which one we're referring to. So when I do angle R, I'm going to put this one right here. I'm going to put it right there. This is angle VRP. That we could also list as PRV. It doesn't matter what the out 2 are, they could be switched, but the middle letter has to be an R for that. And then this angle here, right here, let's make that actually point right to the angle there. So this angle right there is, if I start with the X, I'm going to get angle XRN. So I have to use 3 letters to identify this one because of the fact that that R has multiple angles there. These last 2, this could be listed just as angle X because there's only one angle there, and this could be listed as angle N. So notice that we could list it with 3 letters, but some we could list with just 1 letter. But these 2, make sure you list with all 3 letters. All right, so let's go back to our vocabulary from yesterday just to review a little bit. So on our agenda, notice the next thing we're going to do, vocabulary and problem review. So the vocabulary we did yesterday, we'll be using quite a bit today. We talked about vertical angles, those angles that are opposite are congruent. If we've got parallel lines, you've got corresponding angles congruent. If we've got parallel lines, we've got alternate interior angles congruent. And then if we've got parallel lines, these alternate exterior angles are also congruent. We'll be using that today. Also, we've got included angles. Included angle means if you've got 2 sides coming together to a point, that angle there is the included one. That's what it means. Or if included side, if you've got 2 angles here, the side between them that joins those 2 angles together, that's the included side. So included means between, where those 2 angles come together, that side, or where those 2 sides come together, that angle. So that's the vocabulary we did yesterday. Let's go ahead and take a look at some problems here, just to review a little bit. I'd like you to pause the video, and I'd like you to, on these 2 problems, state which triangles are congruent, list the letters for them, and then give the reason. We had side, 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 or side angle side yesterday. Give the reason why they're congruent. pause the video, then come back in just a moment and check how you did. All right, now that we're back, let's take a look at this one. This one, notice we've got two pairs of sides congruent here, and these two pairs, so the single tick marks and the double tick marks. Now we don't have these other sides congruent, and we don't have marked any angles congruent. But like we just talked about, these vertical angles are congruent. So now we have these two sides coming together to that angle. That means that we've got by side, angle, side, these two triangles are congruent. Let's list them in corresponding order. If I start with the W and go to the Y and then over to the X, I'm going to make that congruent to, now again I started with the W, so that was on the single tick mark, so I'm going to start with this V, and then I went to the middle here for the Y, so that corresponds to the Y, down the single tick mark, and then up the double, and that gives me a Z. So make sure you follow it in the same corresponding order of how the tick marks or the congruencies have been listed. Over here, notice that these single ones are congruent, these double ones are congruent, and these triple ones are congruent. That means we can say that the triangles are congruent by side, side, side. Now let's list the triangles. Okay, so this one I'll start with the H, go up the single, H, J, K is congruent to. On this one, I started at the single, I went up that toward the double, so M, P, Q for our congruency corresponding. All right, now let's do a little bit of review of some properties because we'll be using these in proofs. The word reflexive means that something is equal or congruent to itself. I'm going to use the word congruence here because with triangles we tend to use congruence. So we'd say, we're going to say here either side, a side is congruent to itself, or we could say, the second one would be say, an angle is congruent to itself. All right, so why that's important, like if I did an angle, I might say angle A is congruent to angle A. You might say, that makes a lot of sense. Why do you even have to say it? Well, you'll see in some diagrams, A might be the angle in two different triangles. So we want to account for it, maybe in side, angle, side, so we might have to list it. Same thing with sides. We might have side AB be the side of two different triangles, and if that's the case, we want to use it as one of the sides in our either side, 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 or side, angle, side. So we might need to use reflexive. And just a reminder of transitive, this is a property we've used a lot recently, but what it means is if sides are, if two things are congruent to a third thing, then they're congruent to each other. If two, I'll put items, are congruent to a third item, then they are congruent to each other. Okay, so that just is the way we set up with three different things that they might be able to transfer the congruence to each other. Okay, usually what we say is like if we have angle A is congruent to angle B is congruent to angle C, angle B is congruent to both A and C, and so what we can conclude then is angle A is congruent to, go over on this side, is congruent to angle C by transitive. Okay, that works with sides as well. All right, now that we've got some review done, some vocabulary, let's start doing some proofs. We're back to doing some two-column proofs for these, and I want you to analyze this again, looking at the diagram. Set your goal by looking at what's given to you. Notice I'm given AB, please mark on your things the Google Forms wouldn't mark these, so please put the markings over the top of these as segments, okay? It says that AB is congruent to CD, so I'll mark those two. And it has AC congruent to BD. Now notice we've got two pairs of sides congruent. Either we need another pair of sides for side, 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 or the included angle. Well, notice that this side is this BC is in both triangles. It's congruent to itself. So I'm going to use side, side, side and use that reflexive idea that something is congruent to itself to get that third pair of sides. If you have to, you think of this as separating them, okay? And if you separate out the other one, okay, this BC, notice, is the same in both of the triangles. And so we're going to say that those are congruent to itself on the back. All right, let me scroll up a little bit. So the first statement here, we're given that AB is congruent to CD and AC is congruent to BD. That's given. Second step, I'm going to use that idea that I just talked about, reflexive, and state that BC, that side, is in both triangles. So I'm going to state that it's congruent to itself. So I'm going to mark this as my third side. And that's by the reflexive property. It's a new property we talked about in topic 1, but we want to make sure we use it now. We'll use it a lot more frequently in these proofs. Now the third one, I go ahead now that I've got all three sets of sides congruent, I'm going to say that the triangles are congruent. ABC is congruent to triangle DCB. That's by side, side, side. I've got the two pairs of sides here and the third pair there. I've got my triangles congruent. So there's one proof. You might want to pause the video to make sure you get all the steps down. Let's take a look though, after you come back, at another proof. Let's take a look at these two triangles and prove these triangles congruent. Now notice it says that, again, if you could just put a segment marking over the top here, and a segment marking over the top of this one. It says that MV, this is congruent to PV. Okay, so those two are congruent. It also says V is the midpoint of KT. Now what do we know about a midpoint? It splits that segment into two congruent segments. So I'm going to be able to show that these two are congruent, but I gotta use the definition of midpoint to do that in just a moment. Notice now I've got two pairs of sides congruent. I now will be able to say, because these are vertical angles, by side angle side. So that's the way we think through the proof. Let's go ahead and write it down. So our given is that MV is congruent to PV, and V is the midpoint of KT. Okay, that's our given statement. Now let's go to our second step. I'm going to use the fact that V is the midpoint, and now that gets me the next step of saying that KV is going to be congruent to TV, and that's by the definition of midpoint. Third step, remember I had to get those angles in order to do side angle side, so I'm going to say my angles. Now V has several angles there, not just one, so I can't just use angle V. I'm going to have to do angle MVK, use three letters, is congruent to angle, let's do PVT. Notice I followed up the single tick mark, and then I went to down the double, so PVT. Those are the angles, and that's by vertical angles are congruent. Now once I've got that, I now have my side angle side. So I can state that the triangles are congruent, MVK with the triangles. Notice these were angles. We weren't quite there yet. We had needed sides and angles, so these were angles congruent. Now I state that these triangles are congruent. So they look similar, but I went from angles here. Now I've got all I need for the triangles to be congruent, which is my proof statement, and that's by side, angle, side. Side, included angle, side. All right, there's our next proof there. So we got a couple proofs under our belt. Let's go ahead and have you try this one. You try this proof here. If you pause, maybe. Now we've come to the one that we want you to try. Now let's first of all make a couple changes. I'd like you to change this. Cross this one out here, the first one, and let's make that instead AC congruent to, let's make that congruent to MP. Okay, first do that, then put segment markings over the top here. Now what I'd like you to do is go ahead and try this one. Make sure you give it a couple extra steps after you're given. See if you can try a few things, set a goal for yourself, and then come back after you paused it, the video, and check to see how your solution agrees with mine. All right, let's take a look. Let's see how we did on this. So let's mark AC, I've got congruent to PM, okay, and then I've got CB congruent to PN. We want to now prove those triangles congruent. Now I've got two pairs of sides congruent. I either need the other pair of sides, which I asked you to cross out because I want to try something different. Notice it has that these are parallel lines. We can now use, I'll mark it in blue here, that these two angles are congruent because they're alternate exterior angles. That's what we use for the goal for this one. So let's start off by stating our given. So AC is congruent to MP, and we've got that CB is congruent to PN. All right, that's our given. Second step, let's go ahead and use that alternate exterior angle idea. Now because there's multiple angles at both C here and P, we got to use all three letters to mark our angle. So we go with MPN and ACB. So angle ACB is congruent to angle MPN. And that's by parallel lines leads us to know that alternate exterior angles are congruent. That's our abbreviation. If you want to just put alternate exterior angles are congruent, that's the name of the theorem. And the third step, now that we've got side, angle, side, we can state that the triangles are congruent. ACB is congruent to triangle MPN. That's by side, angle, side. All right, so now what we have is we've tried a few example problems. I've shown you a few, you've tried a few. You're gonna start working on some of your own proofs, and so we're gonna be seeing more and more proofs. Make sure you start with setting a goal for yourself. Are you shooting for side, 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 or side, angle, side with the given information, and then follow through on getting all the steps to get there.